Hey, it's Mr. E here, and in this video I'm going to show you how we can use trigonometry to find missing sides. So here are some steps and guidelines that I will use to work out example 1 that you see here to the right of your screen. So instead of just reading through the steps, I'm going to show you how each one applies to example 1 as I go through example 1. So let's go ahead and read example 1. It says, in triangle ABC, the measure of angle C equals 90 degrees, the measure of angle B equals 55 degrees, and the measure of BC equals 5.2 feet. Find the length of AB to the nearest foot. So our first step says to draw the picture described in the problem, if necessary, and it is necessary to do that here. So I will begin by drawing a right triangle. And the reason it has to be a right triangle is because it says that triangle ABC has an angle that measures 90 degrees. So I have to draw a right triangle. So, sorry about that, that's just a bell ringing. Angle C has to be 90 degrees. And since this is triangle ABC, I need a vertex of A and a vertex of B. The most important thing, though, is that angle C gets labeled 90 degrees, so that's why that was the first thing that I did. After that, it doesn't matter where you put the A or the B, but you have to first make sure that angle C gets labeled 90 degrees. Okay, then it says make sure the sides are properly labeled. Label the unknown side label the unknown side X, it says. So we are being asked to find the length of AB, and that's a side. If you see two letters, it's talking about a side. So side AB is our X. So I'm going to label that X. And then we are given that side BC, right? Two letters, side BC is 5.2, so I'm going to write 5.2 right over here. Whenever you label the measurement of a side, make sure it goes outside of the figure, not inside the figure, because you might confuse it with an angle. And just put it in the middle of the line segment that it refers to. So 5.2 refers to segment BC, so that has to go in the middle of the line. That's why I put it there. Okay, the third step says make sure the angles are properly labeled. So we already labeled angle C 90 degrees. Now we got to label angle B 55 degrees. So I'm going to write 55 degrees right over here. So angle B is 55 degrees. So step 1 is done, step 2 is done, and step 3 is done. Step 4 says identify the hypotenuse. So the hypotenuse is the longest side in the triangle, and it's also opposite the 90-degree angle, so this is the hypotenuse, side AB. Then it says identify the adjacent side with respect to the given angle. So when it says adjacent, that means next to, and respect to the given angle, so that's the 55-degree angle. That's the given angle, okay? Not the 90-degree angle. I know the 90-degree angle is also given, but you're never going to use the 90-degree angle for identifying the adjacent side. Okay, you're going to use the other angle, and in this case, it's the 55-degree angle. So with respect to the 55-degree angle, the adjacent side, the side that's next to it, is side BC. So this is adjacent. It's next to it, the 55-degree angle. It's right next to it, and it's not the hypotenuse. That's what makes it the adjacent side. And that's supposed to be a J. Need to fix that. Then it says identify the opposite side. So we have a blank for the opposite side. There's nothing there, but that is the opposite side. The opposite side is across from the given angle, 55 degrees. And it's not a part, or it's not a, let's say, line segment that makes that angle. So what I mean is, line BC and line AB make the 55-degree angle. The opposite side is not one of those lines. Then it says determine what is the appropriate trig ratio. So we have an x for the hypotenuse and we have a 5.2 for the adjacent. And our opposite side is just blank, so we don't need our opposite side. So what we have is hypotenuse and adjacent. So we're going to use cosine. So that's the most appropriate trig ratio to use here, cosine, because of that hypotenuse and adjacent. And since the opposite is blank, I'm not going to use the opposite side. So I'm going to write the formula. So it says the cosine of the angle equals adjacent over hypotenuse. Okay? So now I have to substitute. So it's going to be the cosine of the angle. That's the 55 degrees. That's the 55-degree angle. Equals the adjacent side, that's 5.2. Over the hypotenuse, and that's our x. And see, that's why this formula works for us, because it relates, like it puts together in an equation the missing side and the knowns. So that's why this formula works for us, right? We're only going to have one unknown here in this formula. Okay, so then it says simplify the trig value, round trig values to 4 decimal places. So we're going to need our calculator for that. So make sure that you are in degree mode. So there's my degree mode. And it's going to be the cosine of 55 degrees. And we're going to round that to 4 decimal places. So we get 0.5736 equals 5.2 over x. So we got to solve for x. So we're gonna put this over 1. By the way, if you're wondering why this is a 6 instead of a 5, is because I rounded it. Since I'm rounding to 4 decimal places, I look at the 5th digit, and if it's 5 or higher, I'm just going to round this up. So we're going to solve for x by cross multiplying. So we got our butterfly wings here. So we're going to get 5.2 times 1, that's just going to be 5.2, equals x times 0.5736. We want to get x by itself, so we got to do some inverse operations here. So divide both sides by the number that's next to the x. So divide both sides by 0.5736. 0.5736. These will cancel out, and I'm going to be left with x over here, and I get x equals 5.2 divided by 0.5736. So x is approximately, and I'm just going to truncate this, 9.065, or why don't we just round it to the nearest foot, right? It says here to round it to the nearest foot. So let me actually go ahead and follow that, right? And that was that's the last step. Round your answer according to the question. So I almost blew it there because I didn't go back and read it. So I have to round to the nearest foot. So that's rounding to the nearest whole number. So I'm going to look to the number right after the decimal. So this is going to be 9. So x is equal to 9. That's our final answer. Okay, so that's pretty much how you're going to use trig to find the missing side. In this example, I use cosine because I was given the adjacent side and I was looking for the hypotenuse, but it won't always be cosine, right? If I was given the opposite side and I was looking for the hypotenuse, then I would use sine. So you have to pay attention to those things. That's why we spent time in class going over that. So I do hope this helps, though. Have a good one.